Welcome to the podcast. Today, we're diving into the fascinating world of artificial intelligence, specifically how well AI can remember and use information in long, complex conversations. We'll be exploring a new and important resource called the LOCOMO dataset, which is helping researchers understand the limits of AI memory and how to overcome them. Let's first start from the challenge of long-term memory in AI. So we're used to chatbots and virtual assistants, but these often struggle to keep track of a conversation that goes beyond a few exchanges. Current AI models are often evaluated on short conversations, typically around 5 sessions or roughly 1,000 tokens, as was noted in the research. But what happens when we need an AI to remember information from many sessions over a longer period of time to engage in a truly long-term conversation? That's where the challenges begin, because existing datasets are not adequate for assessing long-term memory. This is a critical issue because if we want AI to have engaging and useful conversations that feel natural, these systems need to remember what's been said and use that to respond empathetically, consistently, and usefully. Imagine forgetting details about your friend's life every time you spoke to them. That's essentially what happens with current conversational AI when interactions go beyond a short context window. Secondly, let's look into the LOCOMO dataset. To tackle this problem, researchers have introduced the LOCOMO dataset. This isn't just another collection of conversations. It's a unique resource of very long conversations, created through a clever human-machine pipeline. This pipeline uses LLM-based agents to generate dialogues, and then has human annotators verify and edit the conversations to make sure they are realistic. What makes these agents so special? They are given unique personas, each with details like their objectives, past experiences, daily habits, and relationships. They also have temporal event graphs, which are like timelines of causally linked events in their lives, adding depth and continuity to the conversations. Think of it as giving the agents a realistic life story, which then guides the conversation. These agents also have a reflect and response mechanism that helps them recall and reflect on previous conversation history. The agents can even share and respond to images, creating multimodal dialogues. The resulting conversations in LOCOMO are significantly longer than previous datasets. Each conversation averages around 300 turns and 9,000 tokens, and may span up to 35 sessions. The human annotators ensure the quality of the generated conversations by fixing inconsistencies, removing irrelevant images, and verifying the grounding of the conversations to the event graphs. Let's now look at how to evaluate long-term memory with the LOCOMO benchmark. Now that we have this dataset, how do we use it to test an AI's long-term memory? The researchers have developed a comprehensive evaluation framework that includes 3 core tasks. Question answering, QA. This task tests the model's ability to remember previous conversations. The questions are designed to test different types of memory and reasoning, including single-hop questions that require answers from a single session, multi-hop questions that need synthesizing information across sessions, temporal reasoning questions, open domain knowledge questions, and adversarial questions designed to trick the agent. Event summarization. This task measures the model's ability to recognize long-range causal and temporal connections. The model must summarize the events within a designated time frame, and this summary is compared against the agent's event graph to assess the understanding of event dynamics. Multimodal dialogue generation. This task evaluates the agent's ability to maintain a consistent persona and narrative over time in the dialogue. It measures how closely the generated dialogues and image-sharing behavior align with the ground truth multimodal dialogues present in the dataset. Lastly, let's dive into experimental results and key findings. The researchers tested a range of models, including base LLMs, long-context LLMs, and Retrieval Augmented Generation, RAG techniques. Here are some key findings. Limited context models struggle. Models with limited context windows struggle with the long conversations in the LOCOMO dataset. Long context models hallucinate. While long context models showed some improvement, they are prone to generating hallucinations and performed poorly on adversarial questions. They also didn't perform better than base models on the event summarization task, possibly indicating they are not using their extended context effectively. RAG is effective with observations. RAG is more effective when the conversations are transformed into a database of observations, which are assertive statements about the speaker's life. This is because retrieving information from a structured database of observations is more efficient than retrieving information from raw dialogue. Temporal reasoning, open domain knowledge are difficult. LLMs struggle with temporal concepts and open domain knowledge in dialogues, even with RAG. Incremental summarization with base models was the best approach for the event summarization task, and long context models did not perform as well. Training models with retrieved observations lead to improved multimodal dialogue generation. In summary, this research shows that while long context models and RAG can help, current LLMs are still far from perfect when it comes to truly understanding and remembering long conversations. Before we wrap up this episode, let's also look into the limitations and broader impacts. The LOCOMO dataset and study have some limitations. Language. The dataset is in English only. Closed source LLMs. The study used commercial APIs for the LLMs, which means the results can't be fully reproduced with open source models. Evaluation challenges. Evaluating long-form text generation is difficult, as LLMs often produce verbose answers, which complicates the evaluation of their correctness. Multimodal limitations. The images used in the dataset are sourced from the web and might not show long-term visual consistencies found in real-life photos. The research also raises some important ethical considerations. Parasocial relationships. Realistic conversational agents might lead to users forming parasocial relationships with them. Misinformation and bias. Multimodal LLMs could potentially spread misinformation and biases. Over-reliance on generative agents. There is a risk of using synthetic data to substitute for real-world interactions. The LOCOMO dataset is a significant step forward in the field of conversational AI. It highlights the challenges of long-term memory for LLMs and provides a valuable benchmark for future research. This project emphasizes the need for methods that move beyond short-term conversational contexts and structured information about speakers and retrieval-based methods in order to create truly conversational AI. Thanks for tuning in. Join us next time as we delve into another aspect of AI research.